proportion z-test problems are located in section 8.4 of your textbook. For the proportion z-test problems for true population proportion, they are types of z-test. The location on the calculator, you will go to Stat and then arrow over to Test, and it is number 5, one prop z-test for true population proportion. Again, that is section 8.4 of your textbook. And P sub 0 is going to be the claim. X, obviously, and N will tell the calculator what P hat sample proportion should be. So remember, in like a class of 40 students, 30 students decide to go home over Thanksgiving break. So that's 30 out of 40. X would be 30 and 40 students would be your sample size. And that means 75% of the students in that class would go home over Thanksgiving break. That's 30 out of 40. And then these three options, not equal to, less than, and greater than, you are telling the calculator what your alternative hypothesis should be. And therefore, it's two-tailed, left-tailed, or right-tailed. And then finally, calculate. I will be utilizing the calculator when I go over the very first problem with you guys. Before I do that, though, I want to turn to the lecture notes and remove the calculator. The first problem in the lecture notes looks like this, and I am going to cover that problem. But before I do so, I want to write out the three possibilities for setting up these problems. If it is a two-tailed proportion z-test for true population proportion, P is equal to a number in the null, but P does not equal a number in the alternative. This is two-tailed proportion test, and it's a two-tailed proportion z-test. For the right-tailed proportion z-test, the alternative P is strictly greater than a number, but the null is less than or equal to a number. And this would be called a right-tailed proportion z-test for true population proportion. And then finally, the left tail, the alternative P is less than some number, but the null is greater than or equal to some number. And this one would be left-tailed proportion z-test for true population proportion. Not equal to, greater than, less than. Remember, greater than points to the right, so it's right-tailed. Less than points to the left, so it is left-tailed. Connect Math and the new edition of the textbook will look like this in the two-tailed. P equals a number. P does not equal a number, so they do agree. But with the right-tailed and left-tailed, the null is P equals a number, and the alternative here is P greater than a number for the right tail. For the left tail, the null is P equal to a number, and the alternative is P less than a number. Again, with the new edition of the textbook, the null statement always has equality. The alternative is the same as the old, not equal to, greater than, and less than. But these word problems still use phrases like at most, which means less than or equal to, and at least, which means greater than or equal to. So I feel these options are still better in the old edition of the textbook. The test statistic this time is going to have the following formula. Z is equal to P hat, which is your sample proportion, minus P, which is your claim from step number 1, the setup, divided by the square root of P times Q divided by N. P hat, again, is equal to x divided by n, and that's called your sample proportion. P is going to be your claim, and to find Q, P plus Q is equal to 1. Notice that under the radical here, P is the claim. It's not P hat times Q hat, but it's P times Q. And if we know P, which is our claim, we will be able to know Q because together they add up to equal 1. That means that Q is 1 minus P, which is 1 minus the claim. And basically that's it as far as new material. It is a type of z-test, so we use the z-table to find the critical value or values, and we use the z-table to find a specific p-value, and the p-value is found from this particular test statistic. I'll remind you again that if it's two-tailed with the traditional method, you have two critical values, and that z equals plus and minus some number. If it's right-tailed, you have one critical value, and that is z equals some positive number. And if it's left-tailed, you have one critical value, and that is z equal to some negative number on the z-axis. And those indicate, in the traditional method, the critical values mark the rejection regions from the non-rejection regions. So two-tailed proportion z-test, two critical values. Right-tailed proportion z-test, one critical value, it's positive. Left-tailed proportion z-test, one critical value, and it's negative. Let's start and look at problem number 1. And I do want to go over the traditional method with you first. Remember, for a proportion z-test for true population proportion, there are no conditions to meet. You just have to know that it is proportion. A recent study found that at most 32% of people who have been in a plane crash have died. In a sample of 100 people who were in a plane crash, 38 died. Is the study statement believable at alpha equals 0.05? So the level of significance, or alpha, is 5%. We have to figure out that, first of all, this word problem does not mention the word mean or average. It does not mention standard deviation or variance. As a matter of fact, it gives a percentage here that at most 32% of people who've been in a plane crash have died. In a sample of 100 people who were in a plane crash, 38 died. Is this study statement believable that at most 32% of people who've been in a plane crash have died? That is the claim. Is the study statement believable? I am going to circle at most 32%. If you do not know what at most means, you will go to your phrase sheet and look up at most. It is the symbol less than or equal to at most. Off to the side, I wrote down my sample information. They surveyed 100 people, or they collected the information from 100 people who've been in a plane crash and found that 38 out of the 100 died. This is going to allow you to calculate p-hat sample proportion. Test the study statement or claim at alpha equals 5%. So therefore, p-hat is 38 out of 100, and that's 38%, or 0.38. So that's the given information. Now the claim. Is the study statement believable? The claim is going to be P is less than or equal to 32%. Change the 32% to a decimal. At most means less than or equal to. So a study makes this statement. Is the study statement believable? Test this claim or this statement at alpha equals 5%. When you go to your possible setups, you look for your symbol here, and even though it says mu, you could imagine that they have P here on the sheet, population proportion. and look for the symbol at most. It occurs in the null, and then greater than occurs in the alternative. So it is a right-tailed proportion z-test. And I would cut and paste this to my work, but instead of having mu, I would have p. And that's exactly how I received step number 1 of the traditional method. And this is a right-tailed proportion z-test. The claim has to be the null because it says at most. And the alternative greater than points to the right. Therefore, when it comes to finding the critical value, you shade the right tail, and that is all of the given alpha, which is 5%. In this situation, you could do invert norm, and the area below that given alpha is 95%. You will receive a positive 1.64, but you should know that it would be a positive 1.65. You could also go to your z-table and look up the area below the unknown positive z here, which is your positive critical value, and the area below it is 0.9500. This area below it, because this is 0.5 and this unshaded area is 0.45, together that's 0.95 below, and there's 5% above it. If you look up 0.95 in the table and work your way out, this area falls halfway between two values. Go with the z-score that gives you the larger absolute value, and you have to decide between 1.64 and 1.65, so go with 1.65. Again, this is chapter 6. This is not new material. Either do invert the norm, and yes, you'll get 1.64, but I think you should know by now to go with 1.65 from the table, or use the 2-page z-table to look up 0.950. The 2-page z-table, if you look up 0.950, which is the area below it, you are here. And it falls halfway between these two values. Work your way out and up. You have 1.64, 1.65. Go with the z-score that gives you the larger absolute value, and that's a 1.65. That's that very special case in chapter 6 that we spoke often about. Regardless, the critical value that indicates the rejection region in the right tail is a positive 1.65. Test statistic time. The p-hat that we found was 38%, and the claim from step 1 is that it's at most 32%. That's the claim, so in place of p, put 0.32. If p is 32%, then p plus q must equal 1, therefore q is 1 minus 32%, which is 68%. Therefore, under the square root symbol, you have p times q divided by your n, because they did sample 100 people that have been in a plane crash. You should get 1.29 as your test statistic, and I'll show you what that looks like in the calculator. Parentheses 0.38 minus 0.32, close that in parentheses. And that's going to be enter, divided by the square root. And you do need some parentheses. That's going to be parentheses 0.32p times 0.68. Close that in parentheses under the radical. Divide by 100 and arrow out from underneath that radical. And this is the newest edition of the TI-84 Plus, so you will have to arrow out of the radical, the square root symbol. Press enter. And to 2 decimal places, because it is a type of z-score, it's a z-test, is 1.29. Stat and test number 5 may be a little bit easier. P sub 0 is the claim of at most 32%, so put in 0.32. X In 100 people who were in a plane crash, 38 died. So 38 died out of N, which is 100. And this test was right-tailed, so the alternative was strictly greater than 0.32. So go back up and remind yourself that your alternative was greater than 0.32. And then calculate. Your test statistic Z is 1.29, which is the same as formula. And in just a moment, we're going to do the p-value method for this problem, but it is 0.0992 for the p-value that you receive on the calculator. Put your test statistic in the picture. 1.29 falls in the non-critical, non-rejection, non-shaded region, keyword non-rejection region. So do not reject the null statement because of where the test statistic falls. Non-critical, non-rejection region, do not reject the null. So we're not rejecting this null statement, and it just so happens that our claim is the null, that it's at most 30, and that's from up here. Claim is null, do not reject the null. So summary statement time. The claim is the null that says at most 32% of people who've been in a plane crash have died. Do not reject the null statement. So there's not enough evidence to reject the claim that at most 32% of people who've been in a plane crash have died. There's not enough evidence to reject the claim. That doesn't mean we say the claim is true just because we cannot reject it. All we can say is there's not enough evidence to reject the claim that at most 32% of people who've been in a plane crash have died. Therefore, beta, or a type 2 error, is the possibility that we made a mistake somewhere. Even though we'll never know that, that comes from not rejecting the null hypothesis when it could be false. Not rejecting something that's false would be a possible mistake. So it's beta this time for this particular word problem. And I have that decision or summary statement stated here. So let me show you that. There is not enough evidence to reject the claim that at most 32% of people who've been in a plane crash have died. And still beta, type 2 error, not rejecting the null hypothesis when it could be false, is the possibility of mistake. And the p-value method for this problem I would like to show you, if it is possible. It may not be possible. What we would have to do, and let me remove this. This is actually not in your lecture notes, so we'll see if it's possible. With the p-value method for this same problem, the first step is the same. P is less than or equal to 0.32. P is greater than 0.32, and the claim is the null. At most 32% of people who've been in a plane crash have died. Step number 2 of p-value method is to go ahead and determine the test statistic. I'll say TS. And that's the p hat minus the p over the square root of p times q over n. And that's when we just got a 1.29 for the test statistic. And then p-value. You would draw yourself a z-axis, bell-shaped curve, mean of 0. Put your test statistic on the axis where it should fall. And you would find this area, and this would be your p-value. You do not have to double it because it's a right-tailed z-test for true population proportion. You could do normal CDF and put in 1.29 comma E99. 1.29 out to positive infinity, Or look up a 1.29 in the 2-page Z-table. And you would actually be looking up a Z-score of 1.29. So left finger on 1.2, right finger on 0.09. Your two fingers meet at 0.9015, which is the area below 1.29 on the axis. And I'll put that in the picture. That's this, 0.9. 0.15. That means that the area above it, which is your p-value, is 1 take away the 0.9015, and that's because the total area under the curve is 1. So if you say 1 minus the area below it, you receive the area above it, 0.0985. And that's the one you receive by hand. As a reminder, the one on the calculator was 0.0992. To 4 places accurately, 0.0992 from the calculator. The one that I will wish for you to give me is this one, the one you find by hand with the table. And this is the one with the calculator. Now, step 4 is decision. You would do your alpha box p-value. Alpha was given to be 5%, and you could use either p-value 0.0985 or 0.0992, and you would see that alpha's less than. According to the sheet that we have with our steps, if alpha is smaller or less than, do not reject the null statement here. Alpha less than. Do not reject the null. And that's the same decision as with traditional. Do not reject the null hypothesis that says P is at most 32%. And I'm not going to write down the summary statement because the summary statement is the same as before. So refer to the summary statement on the sheet. Or go to your diagram. And the one on the sheet, as a reminder in your lecture notes, because the claim is the null and we do not reject the null, there's not enough evidence to reject the claim that at most 32% of people who have been in a plane crash have died. And that concludes problem number 1 in terms of z-test problems. I would like to show you problem number 2, and it does seem like all of these problems are very negative. Experts claim that 10% of murders are committed by women. Test this hypothesis if in a sample of 67 murders, 10 were committed by women. Use alpha equals 1%, or your level of significance is 0.01. So we need to look at that one. If you notice with that one, I do focus on the p-value method, but I could also show you the traditional method when we're done. The given information is that experts claim that 10% of murders are committed by women. Test this hypothesis that it's exactly 10%. If in a sample of 67 murders, 10 were committed by women and alpha is 1%. So p hat is 10 out of 67, and if p hat is not nice, just like in chapter 7, you round to 3 places accurately, and so that's 0.149 p hat. As far as your setup, and this is the p-value method, experts claim that exactly equal to 10% of murders are committed by women. Test this hypothesis. So exactly equal to means, with your phrases, exactly equal to, when you go to your possible setups, you're looking for the one symbol that says exactly equal to, and it's the two-tailed proportion z-test. The null says exactly equal to 10%, and the alternative, therefore, would be not equal to 10%. And so, therefore, it's a two-tailed proportion z-test, and the claim is the null. That's what we're testing, that 10% of murders are committed by women, exactly 10%. It didn't say less than 10% or greater than 10%, or at most 10%, or at least 10%. It is exactly 10%. The second step of the p-value method, we don't find critical values, would be the formula here. And if the claim p is 10%, then q has to be 90%. So p hat, 0.149, minus my claim of 10%, divided by the square root of my claim, times q. So p plus q must equal 1. The claim is 10%, q is 90%, divided by 67. Put this in your calculator, and you should receive a test statistic of 1.34. With this problem, the test statistic is 1.34. And we use the test statistic to find our p-value. Since this is a two-tailed z-test, even though it's proportion, put your test statistic here on the z-axis, and you would find that area above it, and then double it. Again, you could do normal CDF, or you could look up 1.34 in the two-tailed, in the two-page z-table. With this one, normal CDF would look like this. And you would do 1.34, comma E99. And that would give you area 0.0901. And since it is two-tailed proportion z-test, we would double that, and that would be by hand 0.1802, or 2 times 0.0901. So here's your p-value by hand, using the two-page z-table or normal CDF. The calculator going to one prop z-test would give you 0.1790. And I'm going to show you normal CDF first. Normal CDF is your test statistic of 1.34 all the way out to positive infinity. And that's 0.0901 in the right tail, but since it's two-tailed, double it. So there's the p-value by hand. If you decide to use your z-table, you would look up a test statistic of 1.34, and the area below it would be 0.9099 here. 1.34, 0.9099. And I'm going to draw a different picture for this because the picture I have in the lecture notes corresponds to that one-page z-table that I used to show, but now I'm using the two-page z-table. So this is the area below it, 0.9099. And I'll draw that picture in the lecture. And I believe this is the perfect spot for it. Here's your 1.34, but the area below it is 0.9099, which is this area, according to the two-page z-table. Therefore, the area above it is 1 minus 0.9099, and that should give you 0.0901 in the right tail, and then there by symmetry, negative 1.34. This is also 0.0901. And when you add the two together, there's your p-value by hand. This picture deals with, if you look at these numbers, with the one-page z-table, but this is the current two-page z-table. You look up your test statistic of 1.34, and the area below it is 0.9099. Therefore, the area above it's 0.0901. Or you could do normal CDF to get the area in the right tail, 1.34, E99. Regardless, you would have to double it. And then the next page would be alpha, and alpha was given to be 1%. And then I have the p-value by hand and calculator. And alpha, even though this is not money, that's like 1 penny, and these are almost 2 pennies. So alpha's smaller. Do not reject the null hypothesis, and that said that 10% of murders were committed by women. So we're not rejecting this null statement. Let me show you the calculator for this problem before I give the summary statement. Stat and test, and it's number 5. The claim is that 10% of murders are committed by women, so that's 0.10. And they said that in a sample of 67 murders, 10 were committed by women. And the alternative is not equal to, because it's a two-tailed proportion z-test, and then calculate. And your test statistic, z, is 1.34, and the p-value by hand, if you round to 4 places, is 0.1790. If you round to 4 places, 0.1790. And that's why on the sheet I have 0.1790. Summary statement. Our claim was the null, and we decided to not reject the null. So it's very similar to the last problem, by the way, the previous problem. The claim is the null. We decided to not reject the null. So there is not enough evidence to reject the claim that 10% of murders are committed by women. There's not enough evidence to reject the claim that 10% of murders are committed by women. The possibility of mistake here is beta, a type 2 error. Not rejecting the null when it could be false is a possibility of a mistake. And here's the summary. There's not enough evidence to reject the claim that 10% of murders are committed by women. Now, just so you know, if you did have to do the traditional method with this problem, I'll just help you find critical values. This is traditional. You would shade left and you would shade right, and you're looking for a positive z and a negative z, and this is when you would say alpha over 2, which is 0.01 over 2 in each tail, which is 0.005. And remember, going back to traditional, if you want to find these critical values and it's a z-test, you divide alpha by 2. Alpha is needed to find critical values in the traditional method. And you would do the area below each of these. This is 0.005, but this is 0.995. I recommend doing invert the norm, which is 0.005, and you should get a negative 2.58. So your critical values will be negative 2.58 and a positive 2.58. Critical values are plus and minus 2.58. And those would define your rejection regions. Even if you use the table, you would, 2-page z-table, you would see that it's plus and minus 2.58 for your critical values. So critical values with this traditional method, same problem, plus and minus 2.58. Remember, your test statistic for this problem was a 1.34, and therefore you would put your test statistic in the picture. It was 1.34, and it would fall here on the axis, which is less than the 2.58. It's in the non-critical, non-rejection region. So traditional method, do not reject the null statement that says 10% of murders are committed by women. Do not reject the null statement. So it's the same decision as with this p-value method that I focused on. If you find your critical values, which would be plus and minus 2.58, divide alpha by 2 and do invert the norm, or use the two-page z-table and look up an area of 0.005 or an area of 0.995. When you work your way out, you'll get plus and minus 2.58. So do not reject the null statement. And that concludes problem number 2 in the lecture notes. And I did both methods. P-value was concentrated heavily on, and then I did the traditional by showing you the critical values for this problem. Regardless, here's the decision, and there's not enough evidence to reject the claim that 10% of murders are committed by women. There's not enough evidence to reject the claim that 10% of murders are committed by women. Last problem. And I'll show you this. A team of surgeons has developed a new technique for a risky eye operation to restore the sight of people blinded from a certain disease. Under the old method, it is known that only 30% of patients who undergo the operation will recover their eyesight. Suppose that the surgeons in various hospitals have performed a total of 225 operations using the new method, and that 88 have been successful, recovered their eyesight. Here we go. Test the claim that the new method is better. I used to give this as a quiz when I gave quizzes in statistics, and some students did not know how to set this up. But under the old method, it says that they found that only 30% of patients who undergo the old method of surgery or operation recover their eyesight. And it says they want to test the claim that the new method is better. And that says that it makes the percent P strictly greater than 30% at alpha equals 0.01. So here's the setup. If the new method is better than the old, the percentage is strictly greater than 30%. And if you look for greater than with your sheet, it occurs here. Therefore, the null is less than or equal to, and the alternative is greater than. So, under the old method, only 30% of patients recover eyesight. And then surgeons in various hospitals performed a new operation on a total of 225 people with the new method, and 88 were successful in recovering their eyesight. Test the claim that the new method is better, therefore P is now greater than the 30% that they had with the old method. So this is a right tail proportion z-test. So in the new surgery with the new method, 225 people were operated on new method, 88 people recovered their eyesight, and alpha is 1%. P hat would be X over N, 88 out of 225. So in this sample, 0.391, 39.1% of this sample recovered their eyesight under the new method of surgery. The test statistic, obviously this is the p-value method, is your p hat of 0.391 minus your claim of 30%. And if your claim is 30%, Q is 70%. So P times Q divided by N, 225 people were operated using the new method. And you should get a 2.98 as your test statistic. What is the p-value? Put the 2.98 as a test statistic on the axis where it should fall. And you would actually look up 2.98 in the 2-page Z-table, or you could do normal CDF 2.98, E99, and that area is 0.0014, and that's what you would get for your p-value by hand, 0.0014. If you go to your 2-page Z-table and you look up a Z-score of 2.98, here's 2.9 and here's 0.08. The area below the test statistic of 2.98 is 0.9986. 0.9986. That's the area below the test statistic. 0.9986. And so the picture that I would draw would be a slightly different picture, and I'll try to draw that here. Using the 2-page Z-table, here's your 2.98. The area below it is 0.9, and I've already forgotten, sorry, 0.9986. So the area above it is 1 minus 0.9986, and that's 0.0014 there with the 2-page Z-table. So look up your test statistic as a Z-score, 2.98. The area below it is 0.9986, and then 1 minus 0.9986 is 0.0014. And you do not have to double it because this is a right-tailed proportion Z-test. As far as your decision, alpha was 1%. Your p-value is actually the same by hand and calculator this time. I'll show you that in a moment. Alpha's larger, greater than or equal to, so reject the null hypothesis. And the null statement said less than or equal to 0.30. Reject the null. Now, if we reject this null statement and our claim says that it's greater than 30%, that means in terms of a summary, we put our finger on the fact that the claim is the alternative, and our decision is to reject the null. So the claim says it's greater than 30%. We reject the null that says less than or equal to 30%. There is enough evidence to support the claim that it's greater than 30%, and that means the new method is better than the old method. And so here we are, and here's the summary statement. There is enough evidence to support the claim that the new method is better because that's saying that P is greater than 0.30, greater than 30%. Now this focused on the p-value method. I'm not going to show you traditional method for sake of time. And to be honest, I'm actually currently in a classroom, and a class is about to begin in the classroom I'm utilizing, so I apologize. May have seen that I went through these last couple of problems a little bit too fast. But with this one, I'll just stop at the p-value method. But do go and try to find the critical value for the problem. Since it is right-tailed and alpha is 1%, there's only going to be one critical value, and it's going to be positive. And if you put your test statistic in that picture, you will see that this test statistic falls in the rejection region. So you would reject the null hypothesis, and you would have the same summary statement. So try finding the critical value on your own using this alpha and the fact that it's right-tail proportion Z-test. And you would have the same decision and same summary. I do want to show you the calculator with this before I actually close out this lecture. Stat and test, and it's number 5. The claim is 0.30, 30% recover their eyesight. The new method is better, greater than 30%. In a operation of 225 people, 88 people recovered their eyesight under the new method of surgery. And then the alternative is greater than the claim of 30%. So calculate. Greater than, it's a right-tailed proportion Z-test. And the test statistic is 2.98, and the p-value by calculator is the same as by table, .0014. That's rare, by the way, that they actually agree, table and calculator. .0014. And then again, alpha is greater than p-value, so reject the null, and therefore there is enough evidence to support the claim that the new method is better. Because we rejected the null, there is a possibility we made a mistake, and that's alpha, a type 1 error, rejecting the null when it could be true. And that's the possibility of a mistake. And if you remember, alpha's 1%. So we have a 1% chance in this total problem that we made a mistake here. And we may never know if we made a mistake. All we can say is reject the null. There is enough evidence to support the claim. So alpha type 1 error is the possibility of mistake just based upon our decision to reject the null hypothesis when it could be true. Rejecting something that could be true is a mistake. And that basically sums up proportion z-testing. I hope you see that this type of testing is very, very similar to z-testing for the true mean, z-testing for true proportion. The way that you find those critical values would be the same. Those p-values from the z-table would be the same. And so nothing really has changed except the parameter is different. It's p instead of mu. And that our test statistic formula is different. But everything else pretty much stays the same when it comes to z-testing. God bless you. The next lecture will be chi-square testing for true variance and true standard deviation. And then finally, I will record the practice test. So stay tuned and study these lecture notes. Thank you.